Welcome back, everyone. We are doing grade 11 Exponents Exercise 2.2, question B, D, F, H. Okay. First question is on the screen. So in this one, we're not doing left-hand side or equals right-hand side. In this one, we are going to simplify. So what is my song? My song is always start with prime bases. I don't have prime bases in my first one, so we're going to change, okay? So this becomes 6 is actually 2 times 3. I'm putting that in brackets, and then everything else stays the same, n plus 2. Multiplied by 10, which is 2 times 5, n minus 2, over 4 is 2 squared to the power of n, multiplied by 15, which is 3 times 5 in terms of prime bases, n minus 2. So far, so good. Once I've got that, I'm going to make sure everybody has the exponents that they should. So this becomes, that equals, and this equals, remember your fraction lines, please, 2 n plus 2 times 3 n plus 2 times 2 n minus 2 times 5 n minus 2 over 2n times 3 n minus 2 times 5 n minus 5. Excellent work so far. Now that I've got that, I am going to, you could split if you wanted to. You don't necessarily have to split, because what we're going to do is we're going to do same base and just add and subtract our exponents, right? So no, let's not cancel. I could show you how to cancel, but let's not cancel. Let's do this. Let's start with our 2 base. Okay, so on our top we've got n plus 2, and we have a second one plus, because it's multiplication, we are adding n minus 2. Now we're going to go to the denominator, which is, because it's a fraction line, we subtract 2n. That is our 2 base. Those are all the 2's. Multiply that by our 3 base. That one's got n plus 2 as a numerator. And then as a denominator, we're going to subtract. So minus n minus is plus 2. Please don't make the mistake of the signs. Okay, so technically this ends up being minus n minus 2, which I then simplify into the positive. And then our last one is going to be our 5 base, and that's going to be n minus 2 as a numerator, and so this should be a 2, minus n plus 2 as a denominator. Again, it's minus n minus 2 with n minus 2 in brackets, changing both signs. Now that we have that, we can simplify. Minus 2n, n and n is 2n minus 2n gives me 0, so that cancels out. 2 minus 2 gives me 0, so I have 2 to the power of 0. Let's look at 3. N minus n gives me 0. 2 plus 2 is 4. That is 3 to the power of 4. The 5, n minus n is 0. Minus 2 plus 2 is 0. So that gives me 5 to the power of 0. So that is 1 times, what is it, 81? 81 times 1. So my final answer is then going to be an answer of 81. I hope that made sense to you. Let me know. Okay, next question is going to be D. Okay, D is on the board. First thing that we're going to do is we are going to change to prime bases, right? So we're going to say that this is equal to 2 cubed to the power of n. So we don't need a bracket there. Actually, yeah, okay. Multiplied by, this one is going to be 2 times 3 and that one is n minus 3 multiplied by 3 squared times 1 minus n over 16 is going to be 2 to the power of 4. 2 to the power of 4 n minus 1 times 3 minus n. So we did prime bases. Now let's get our exponents to everyone. So that becomes, sorry, not 4, 2, 4n minus 4 times 3 minus n. Now that we've got that, you can write with the main coefficient base. So this is now 2. We've got 3n plus n minus 3. Now, because of this fraction line, we subtract 4n and we add 4 times 3 n minus 3 plus 2, again fraction base, minus n, which is positive n. Okay, simplify. This is 4 and that's 4. That becomes 0. 4 minus 3 is 1, 2 to the power of 1. N and n cancel out. And this is minus 3 plus 2 is minus 1. 3 to the power of minus 1. So that gives us, if so both of them are 3 and 2. If they go home, basically, you have 2 as a numerator over 3 as a denominator, and that's your final answer. So that was question B and D. Okay. Now I want to go over to question F. Okay, question F is on the board. First thing we do is prime bases. So we're going to say 3 squared. I'm having issues today. 3 squared x plus 3 2x plus 1 over 18 is going to be, 18 is 9 times 2, right? So that is 2 times 9, and 9 is 3 squared. 2 times 9, x multiplied by 2, 1 minus x. Okay, so now we make sure everybody got the right exponents. 3 2x plus 3 2x plus 1 over 2x times 3 2x times 2 1 minus x. Now what's the difference between this sum and the previous sum? I really sincerely hope that you notice that now we have an addition that we didn't have before, which means the way we deal with this has to be different, right? We can't do the same thing that we did last time. In this instance, if you see the plus and minus, you are going to do the highest common factor. If there's no highest common factor necessary, it's because it's multiplication and division. But this time it's necessary. So what are we going to do? Let's split. Can we split this? I'm going to erase it. And I'm going to say, okay, let's split. This becomes 3 2x times 3 to the power of 1, which means now there's a common factor. And the question is, what common factors do we have? Our common factor is going to be 3 2x over here and 3 2x over there. But notice I also have a 3 2x at the bottom. It's not related yet, but I'm going to write it on the same left-hand side. So I'm going to take out 3 2x as a numerator, and I'm going to move 3 2x to the left as a denominator. What's left in my numerator is going to be, remember this is actually times 1. So 1 plus, that's this plus the 3 that remains over there. My denominator, I have times 2x times 2 to the power of 1, if you want to separate it, times 2 to the power of negative x. Okay, so that works out. Now, why did I put the pinks on the left? Because this relationship here is multiplication. Pink times the rest, pink times the rest. I can actually cancel them out. So that's gone. So now on my numerator, I have got 4 over the rest. Okay, so my numerator ends up being 4 over, my denominator is 2x plus 1 minus x. Now this x and that x cancels out, so it's 2 to the power of 1. So what do I have? I have 4 over 2 to the power of 1, which is 2, and that simplifies out to just 2 wholes. Okay, last question is going to be h in this video. Okay, h is on the board. I have 4x, or 4 to the power of x, plus 2 to the power of 2x minus 1 over 2 to the power of 2x minus 1. My first temptation is to cancel 2x minus 1 with 2x minus 1, but I cannot. The reason why is because of this addition sign. I am not allowed to cancel over pluses and minuses. So what are we going to do? I like prime bases. So let's convert our first one to prime base. This 4 will then cancel out, and it becomes 2 to the power of 2. 2 to the power of 2. Okay, now that I got my prime bases sorted out, I am going to split. And if I split, I am going to end up having 2x plus 2x times 2 minus 1 over 2x times 2 minus 1. Next up, we're going to take the highest common factor because we have that addition. So the 2 to the power of 2x is common on all three. I'm going to put that on the left hand side. 2 to the power of 2x on my numerator, and then 2 to the power of 2x on my denominator. So on my numerator, this first term is times 1. So I have 1 left here. I bring down the plus, 2 to the power of negative 1. And then this at the bottom ends up being just times 2 to the power of negative 1. Okay. Can I take out 2 to the power of negative 1 as a common factor? The answer is no, because I don't have 2 to the power of negative 1 in the first term in the numerator. It doesn't exist over here. Okay. So now I can cancel these two out. And then what do I have left? In the numerator, I have, so this 2 to the power of negative 1 means to the bottom, right? So technically I have 1 plus a half, because that 2 becomes a denominator, over a half, because that 2 becomes a denominator, right? So now I have 1.5 over a half. Now the question becomes, how do we deal with fractions? We need to divide fractions. When we divide fractions, we say, okay, I'm going to convert this to a mixed number. So instead of 1.5, I'm going to say 3 over 2 multiplied by the inverse function. Okay, let me write it as a division first. Divided by a half, 3 over 2 divided by 1 over 2 is equal to 3 over 2 times 2 over 1, which then allows me to cancel common numerators and denominators. It gives me a total of 3 over 1, which means that my final answer then is 3. Okay, that is exercise 3.2. Next one is going to be, 2.2. Now we're going to do 2.3, just B and D in the next video.